Good day, listeners and viewers. Welcome back to our online classes on solar installation, maintenance, and supervision. My name is Engineer Mahmoud Ibrahim, and if you can recall, last time we discussed on interconnection of solar PV and batteries. So today we are together with your engineer, Abdul Majid Muhammad Salis. Engineer, on to you.
Good afternoon, all. You're welcome back to our online classes. Of course, if you can remember last week, we treated interconnection on solar charge controllers, where we have seen different connections of PWM and MPPT, maximum power point tracker charge controller and pulse width modulation charge controllers. Okay, today we are going to discuss on the other component of solar system, which is inverter and battery. Okay, what is inverter? Inverter is nothing but a device that usually used to convert direct current into alternating current, which means part of it is direct current, DC, and the remaining part is AC. So DC, energy coming from the battery, from the solar panel, charge controller, and the battery, then 50% of the inverter is DC, while the remaining percent is taking AC, of course. Okay, we have inverter based on waveforms. We have sine wave inverter, we have square wave inverter, and we have modified sine wave inverter. What are these three categories? Pure sine wave inverter is a type of inverter that normally used to take all appliances, be it scientific appliances, home appliances, industrial appliances, and what have you, because it has the rated frequency of 50 hertz. So which means if the inverter is capable of producing the voltage and frequency of 50 hertz, it means it can be able to supply power to any given load. Then if we look at square wave inverter, square wave inverter is a type of inverter that is having a frequency below 50 hertz, either from 30 something, 40, even though below 50 hertz. So if you have a frequency below 50 hertz, definitely the system is not supposed to be giving good response. For example, you cannot connect a scientific appliances like maybe a CNC machine, computer numerical control, like when you have CNC lathe, CNC milling, or if you go to hospitals, those engines, machines that are used, that they used to diagnose people in scanning and what have you, because they have inbuilt computer numerical control, the inverter cannot be able to what? Power those appliances. So as such, you have to go for the pure sine wave inverter. And then lastly, we have the modified sine wave inverter. Modified sine wave inverter is in between. It's neither sine wave inverter and no square wave inverter, which means there is an improvement of frequency. So now if you go for square wave inverter or modified sine wave inverter, you notice if you are or using those inverters at home, when you on the ceiling fan, it will start bringing out humming sound that you'll be hearing that humming sound, wow, wow, meaning that fan is rotating, but the noise as a result of poor or low, the frequency is too low. That is why it is giving out that noise. Or maybe you are watching television. There will be a kind of small ripple that you'll be seeing a flickering on the screen. And you'll be noticing some noise, unwanted noise, as a result of poor frequency. But if you're dealing with pure sine wave inverter, you will not experience such kind of situation. More so, if you are charging your battery, the quality of charging will not be as effective as if you are dealing with pure sine wave inverter, because the battery will be charged within no time, but the quality will not be there, so that the draining of the battery will also be drastically. But if it is a pure sine wave inverter or national grid, you will experience that the quality of charging is there. So this is the categories of inverter based on waveform. And then we have classification of inverters, which is types of the inverter. We have standalone inverter, we have a bidirectional inverter, we have PB inverter, we have hybrid inverter. Even though under hybrid inverter, we also have high voltage inverter, we have microgrid inverter, we have grid-tie inverter, and many more. What is bidirectional inverter? Bidirectional inverter is a type of inverter that is having an inbuilt charger in it because it has what we call a rectifier. Rectifier is a reciprocal to inverter. Inverter normally convert direct current into alternating current, while the rectifier will convert alternating current into direct current, which means you can charge the battery through the inverter, and then you can use the battery and then convert the DC into AC to power the home appliances. That is bidirectional inverter for you. We have hybrid inverter. Hybrid inverter is nothing but an inverter that is having an inbuilt charge controller in it. Nothing more special about it. It is just inverter with charge controller. But normally people used to think about it that if they hear this word hybrid inverter, maybe it's a special made inverter. It's not a special inverter. It's nothing but inverter with charge controller together, embedded together. Okay? We have high voltage inverter. High voltage inverter is also a hybrid inverter that is having or that is collecting an open circuit voltage from the solar panel in form of series connection so that you have higher voltage, but you are going to maintain a small current. That is to say, if you are using a current of, let's say, 15 amps from a particular panel, so even if you connect that panel maybe up to maybe 20, 30, 40, whatever the case may be, depending the capacity, rated capacity from the inverter, because each inverter has parameters. There is what we call a nameplate. From the nameplate, you will see the maximum open circuit voltage or PV voltage that the inverter can take. So if the voltage is, let's say, from 90 to 500 VDC, you have to look at the open circuit voltage from your what? Solar panel. Then you do the interconnection in series. Immediately you get closer to that maximum, you stop there because exceeding will lead to a destruction. You understand? And if you're dealing with a good inverter, it has a protection. Anyhow, if you intend to what? Exceed the limit, it will give you a warning sound. Okay, so now, which means when you have higher voltage, you will maintain the current of a particular solar panel. So that is high voltage inverter for you. Okay, it also has system voltage and voltage range. Okay, this is high voltage inverter for you. And we have microgrid inverter. Microgrid inverter is a type of inverter that is having or that is embedded with solar panel. A solar panel is attached to that particular inverter, which means if you have 20 number solar panel, which means you have 20 inverters. So which means if you are dealing with that type of inverter, you don't require a charge controller. The inverter is attached to the solar panel, then the battery, then you power your load. So basically, these are the inverters literally. Okay, so now we are going to see how do we identify those inverters. Of course, if you can remember, during my introductory part of this program or these lessons, I told you that before you begin thinking of selecting component, you have to do what we call load analysis. Through load analysis, that will give you the actual capacity of what the inverter to be used, the number of batteries and their capacities, the cabling, the panels, and what have you. So, which means this load analysis is also a topic on its own. I think we're going to have a session on that. Now, let us move to a battery. What is a battery? A battery is nothing but a storage. Batteries store energy. All right? So, how does the battery store energy? So batteries store energy through from the solar panel via the charge controller, and then the cable or the conductor will be what will transport the current into the battery. And what type of current do the battery normally use to take from the solar panel through the charge controller is the maximum power current. If you can recall, if you look at the nameplate of the solar panel, we have two types of current, short circuit current and maximum power current. Okay, so our battery is taking the IMP, maximum power current, which is always less than the short circuit current. Okay, what are how many types of battery? Literally, Actually, we have two types of batteries. We have primary cell battery and secondary cell battery. Primary cell battery is the type of battery that is what? Non-rechargeable. For example, like um, radio battery, remote battery, torchlight, and what have you. Those batteries, if you use them and when they go drained, that is the end of it, you just have to what? Discard them and replace them with a new one. That is primary cell battery. Whereas secondary cell batteries, the type of batteries that are what? Rechargeable in nature, which means you can use them. When they got drained, you can also recharge them. We have different types or categories of this secondary cell battery. We have cranking battery, we have deep cycle battery, we have what do you call it, lithium ion battery, we have valve regulated lead acid battery, and what have you. What is cranking battery? A cranking battery is a type of battery used for our what? Our vehicles, for example, like motorcycles, tricycles, cars, and what have you. How does cranking battery works? Cranking battery works based on the principle of what? It actually used to give out the whole of its energy during the ignition process, and that is why it is called cranking battery. Immediately you switch or you intend to start the engine, the battery will tend to what? Give out the total of its energy to make the ignition process possible. Immediately the engine starts, it will go to zero mode. As such, if you notice, either a motorcycle, tricycle, a car, it has what we call a generator. When you are moving with your engine, the generator will be what? Filling the gap, the energy you spent during the what? Ignition process. That is the cranking battery. And then we have deep cycle battery, in which under deep cycle battery we have two categories or three. We have tubular battery, the battery that is having acid and distilled water. Which type of acid is that battery having? Hydrogen tetraoxosulfate 6 acid, H2SO4 with what? Distilled water. And you normally notice that battery, it has 6 compartments. And each compartment is capable of producing 2 volts. When you multiply 2 volts times 6, it will give you 12 volts. And that is the rated voltage of that particular battery. And we have deep cycle battery. And we call that battery maintenance battery. And then we have maintenance free battery, which is what? Gel battery in form of what? Dry cell battery. It normally comes in form of sealed. In fact, you actually don't maintain it. If you really want to do a maintenance to it, number one, you place it in a very conducive atmosphere where there's ventilation, and then you always make sure that the bolt and nut are firmly tight. And then there's no space for what? Partial contact. Okay, and then we have VRLE battery, valve regulated lead acid battery. VRLA battery is a type of batteries that is having low voltage by higher capacity. For example, 2 volt 500 ampere hour, 2 volt 1000 ampere hour, let's say 3 volt 1500 ampere hour. So now, this battery, if you have a system voltage of 12 volt or 24 volt, for example, 12 volt, which means you require 6 of these VRLA batteries before reaching the system voltage. But you have a bigger or huge amount of what? Capacity, which means if tubular or gel battery will last for, let's say, 24 hours, this VRLA will last for, let's say, 48 or even above that. Okay. We also have lithium ion battery, which is a new technology. Lithium ion battery, it has a lot of features. You can switch it on, you can switch it up, you can see the level of the battery status. It also has what we call battery management system, BMS. A battery management system is just nothing but a mechanism that serves as a control, just like charge controller. It always makes sure that you didn't drain your battery. You use a battery based on operational standards. So we have different types of batteries. So basically, this is what batteries are. How do we connect the batteries? How do we connect, interconnect the inverter? I think in our next class, we will take a topic, number one, on load analysis. After load analysis, then we move to those components. we see how to select those components from the load analysis table, going by what the client or what we intend to use. For example, bulb, ceiling fan, television, and what have you. Through those appliances, then we form a table. That table will give us all the information required in selecting the aforementioned component. I remain Engineer Abdulmajid Muhammad Salisu. If you keep following us, next week we're going to discuss on load analysis. See you. Thank you very much. Bye.